But before we go into the details about what Skate does, we wanted to tell you the story of how the MBTA, as a public transit agency, came to build its own custom software. Then we'll go into the why behind Skate, why it got built in the first place. And then to wrap up, Eddie will tell you all about Skate, what it does, and who uses it. First, some history. So Eddie and I are part of the MBTA's customer technology department. On the screen, you'll see a few of our colleagues. Maybe you know them. And here at CTD, our mission is to apply modern principles of research, design, and technology to make our transit system easy for all riders to use. But CTD didn't always exist. So once upon a time, in 2015, Boston got a record-breaking amount of snow. We also got a lot of snow yesterday, so this story is pretty timely. And so, back then, train tracks were frozen, buses couldn't go down roads, delays were unbearable, and there was no good way to share for the T to share with riders what was going on. It was, riders were really disappointed, and it was called Snowmageddon. It really shook the T to its core, and I think the T really realized it had an opportunity at its hands to better to improve how it communicated with riders, to improve the customer experience. So at the time, David Schachter, who's now Chief Business Officer at Transit App, told the T's leadership that we could modernize our technology, we could improve rider-facing information, and so that's how the department was built. He hired developers, designers, data analysts, other product people from TripAdvisor, Zipcar, and other tech companies in the area, as well as government employees. And we built a proper tech team within the agency. And in the 6 to 7 years, I think the department has really proved its value to the agency as well as riders. Just yesterday, I was amazed that the T kept most of service going throughout the day, and that communication was pretty good yesterday because we had a blizzard. But so today, our department, we have 3 program areas. We have rider tools, digital ride, and transit tech. So the tools that they build tools like mbta.com and T alerts and digital pass programs that riders use to directly navigate the system. Digital ride in the middle procures and builds technology that helps riders. So you can think of things like e-ink signs and countdown signs. And the middle screenshot on the screen is actually the same one that you'll see on the Columbus Ave Center running bus lane. The same one that I'm sure a lot of you know and love. And then Transit Tech, which our team is a part of, we build and oversee core service management tech that empowers operation staff as well as creates useful rider data that feeds apps like mbta.com and Google Maps. So I kind of just really quickly went over the story of how we as a department were able to build these kind of tools for riders. But the funny thing about wanting to help riders is that you also have to focus on the folks who run service for riders. And so that'll take us into kind of the next phase. But before I started working at the T, I expected bus service to be a lot more automated. And I now know and understand very well that it is a profoundly human system that relies on quick decision making, countless phone calls, piles of papers, and really factors beyond your control. And so if we think of what do we need to run bus service? You need buses. We have around 800 on the road and at peak times. Bus operators, we have over 1,000 of them. There's also an operator shortage. Then all bus operators must have buses to drive. They need to start at the right place and on time. They need to take breaks, have days off, and if there's traffic, they need to adjust. So there's a lot of moving pieces here. And there's also a lot of people behind this doing lots of different types of jobs behind the scene. And so to work, they have phones, they have radios, and they have piles of paper. So upon thinking of all of this, what we really understood is that bus operations need a connective tissue, a way to be sharing information in real time. And we understood that paper alone isn't going to do that. And so we still want to equip bus officials to have the most up-to-date information so they can get riders where they're going. And so now, an obvious solution could have been to just buy an off-the-shelf modern mobile dispatch app for bus officials. but we couldn't. And I think a lot of you, and I've heard people talk about this in other presentations today, but vendor lock-in, it's real and it's the most pressing challenge we face. Borrowing from a colleague, Dave Barker, bus service is trapped in legacy business and operational practices with roots in the 1990s. And these aging proprietary dispatch systems hold back how we can manage service and the quality of information we can provide to riders. And so these legacy vendors use their micro monopoly status, unfortunately, to gatekeep innovation. And so, that's something that we faced when we wanted to build out Skate, and we just couldn't. We couldn't because of vendor lock-in. Um, Also, existing solutions don't scale to manage many routes at once. So some of our officials at stations, which we call station officials, they're managing like a dozen routes at once. And dispatchers sitting in the operation control center, they manage maybe up to 50 routes at once. So we needed a solution that scaled. And then ultimately, it came down to quality as well. We just didn't find anything on the market that provided the quality that we felt our operations staff need and deserve. So that's where Skate comes in. We decided to build it ourselves. Technology is really good at sharing information very quickly to a lot of people. And so our goal is to make a robust dispatching tool that shares information rapidly to everyone across bus operations working on the problem. Luckily, we're an in-house team of researchers, designers, and engineers, so we're able to closely collaborate with them and build exactly what they need every step of the way. The they, as you'll see on the screen, it's a lot of people. You have dispatchers. We have 18 of them sitting in the operation control center. They're managing all of our routes at a very high level. You have station officials at stations, making sure that buses are passing through and arriving and leaving on time, helping riders as well. You have mobile inspectors kind of in their mobile cars, just driving around, so providing support where needed. And then you have officials at the garages, making sure that there's an operator and a bus to pair and send on their way. Then you obviously have bus operators and riders. Um, and so it's a lot of moving pieces. And when we were figuring out how to build Skate, we knew we had like a great idea. We knew we wanted to build it. There were a couple things that we really wanted to get right. One of them, it was important for us to be able to purchase off the shelf cheap tablets that we could easily manage and upgrade. Just this year, we provided our officials with the most up-to-date Android tablets. So that was one. But I think one of the most crucial things was prioritizing user research and conversations with bus ops leadership. So we're not bus officials. We didn't speak their lingo. We wanted to better understand their physical and mental constraints, how they think, um, how they feel, and all of these things. And so that's why for us, user research has been really crucial to the success of Skate. And then from there, what Eddie will really kind of talk to you about is modern engineering practices and making use of existing APIs, either from existing standards like GTFS real time or provided by vendors like Swiftly. And so before we dive into Skate, yeah, I think these are really nice quotes. Skate is a thing now. In 2019, we launched Skate to over 150 bus officials at the MBTA. That's not counting dispatchers. And about 70% of bus officials use Skate every day. To give you an idea, that's around 90 people. But for decades, these bus officials use the same tool that they call Citrix. In 2020, we were luckily able to retire Citrix and replace it with Skate. And so the two quotes that we chose and put on the screen, I just really like them because they speak to how excited officials are to be using Skate despite being so used to Citrix. So we count that as a monumental success. And before we stop talking, this is something it's an email from one of our bus instructors sent to a former colleague. And I think it's a tribute to her, but also to the Skate team, to just how we were able to closely collaborate to build this tool. And yes, so now that I've talked your ear off about how we got here, Eddie will tell you what Skate actually does. And we can take a quick tour of the main features.
Hello. Yes, so we're going to do a quick little whirlwind tour of the features of Skate. So here we have like a a nice little animated GIF showing kind of like overall flow of the application. But if we go to the next slide, we can start to get into some details of individual features. So the sort of core view that Skate provides, which is similar to what many other CAD AVL systems provide, is what's referred to as a route ladder. So route ladders provide kind of an abstracted view of each bus route and the locations of buses along them, kind of abstracting away the particulars of the geography of the route. And this condenses a lot of information down into one view. So you can see icons representing buses. They are color coded based on schedule adherence. There is also a slightly harder to see, there is a little line from each bus to the location along the ladder where it is currently scheduled to be. And last but not least, we have little ghost icons representing ghost buses. So these are instances where there is, a bus scheduled to be at a particular location along a route, but there is no bus logged in to run that service right now. And so this highlights that to our officials, helping them realize that they, need to try to cover that or adjust other service accordingly. And this view helps them, just catch general things like gapping and bunching and stuff of that nature. Next slide, please. And so like many large agencies, the MBTA does need to do a lot of late evening and weekend bus bridge service to support large scale maintenance on our rail rapid transit system. However, these are not scheduled like conventional fixed route services. We don't draw up a detailed schedule of every trip, run, block, and so forth. And so the problem with this was that our existing CAD AVL system didn't really support seeing all of the buses operating on a particular shuttle route in one place. So with the help of some middleware that our department has to talk to this existing CAD AVL system, we were able to get that data and Inkscape provide a nice, easy map view that shows all of the shuttles broken down by which shuttle service they are logged into running. Next slide, please. Swings view. So this is an interesting, another interesting one. So you may have cases where rather than signing on and beginning their shift at a garage, an operator ends or begins their shift at the end of the route, like at a station. And of course, this is kind of like a delicate, sort of a complicated dance to manage for our officials because you've got a bus coming in from another, potentially another route. And so, and that may be running late and you need to make sure that you have your operator there. And so in MBTA parlance, that is referred to as swinging off and then swinging on. So previously, the way station officials would manage this is that 4 times a year when the MBTA did a new schedule, they would just go through the big paper schedule book and write out a little table of like which runs we're swinging on to which other runs and whatever other information they might need to manage those to have as a reference. And we figured, this is a very kind of manual process they're doing. This is the sort of algorithmic thing that computers can do nicely and provide information to people and then get out of their way to do the, so that they can do the more human focused part of their job. So here's Swings View. It provides the same data and more via the Skate app. Next slide, please. Notification. So this is another one that kind of goes back to the connective tissue idea that Ashli was alluding to earlier. So in our existing CAD AVL system, dispatchers at our operations control center enter notes about service that isn't running for various reasons. So, you might have an operator who's out, you might have a bus that was running but needed to be diverted from its run to something else, and so on and so forth. And it used to be that for people in the field, often it was hard to find out about this information without getting into like a phone or radio call with the dispatch center. To that end, we're able to get that data out of the CAD EVL system via our middleware, and now we're able to provide a nice notification kind of interface in Skate for our users. So whenever somebody at OCC enters one of those notifications, it just shows up to our users seamlessly. Next slide, please. In late view, so this is last but not least. So this is in some ways kind of simple in that it basically aggregates all buses on routes that the user has open that are running behind schedule by a certain threshold or missing. But this is really cool because this has been built specifically with dispatchers as opposed to field officials in mind, simply because they're managing many more routes at once. And so it's simply not, even with the route ladders, it's not as easy for them to kind of keep track of everything at once. And we've had pretty good uptake of this, which is really exciting, especially given that, Skate isn't yet sophisticated enough to do all of their work. So they're, adding basically like another piece of software to their workflow that they're not required to use for the time being. So that's pretty cool. Next slide, please. And yeah, the great thing about, one of the great things about Skate and about much of the software that our department writes is it's open source. It is a public GitHub repository that anyone can go look at under an AGPL license. So it's kind of a little bit of technical details for those who might be interested. It's basically a big web app written with Elixir and the Phoenix web framework as the backend. And the front end is a React single page application written in TypeScript. There are, kind of, as Ashli said, we try to utilize open data formats as much as possible, but for some of these kind of like more operational things or just like aren't great industry standards at the moment. So there's some minor MBTA specific things in the code base, but we try to keep that at a minimum. And in general, we try to follow a philosophy of kind of small pieces that are loosely coupled to each other. So just the Skate repository itself doesn't really have much baggage beyond what's just needed to run a bus dispatching app. And it's fairly modular. And by the same token, there's a bunch of other cool transit related software on our GitHub page that people can explore if they are so inclined.
Yeah, so, well, he gave you the full tour almost of Skate. And so just to wrap it up, well, now we're focused on getting parts of bus operation, different parts of bus operations to use the same tool. So we have a holistic streamlined system. Our next sort of focus is to expand it into the operation control center. Doing so will make it so that we can have so we can improve rider-facing predictions by factoring in decisions like those adjustments that Eddie was talking about. And so our focus is to really make it so that dispatchers can complete their core responsibilities in Skate, whether that's dispatching buses safely, finding buses that are about to go back to the garage, and rerouting them for shuttles, or just monitoring on-time performance. As to how we're going to make this happen, well, we will need to collaborate with our current dispatch vendor to build a read-write API that will continue to power the data that Skate needs. And another critical factor to our success is building trust with our dispatchers. We really need to build a tool for them, informed by them. They have been used to the same tool for years, so we just need to listen. And well, Eddie said this is open source, so if any agency out there is interested in collaborating with us, we do have a Slack channel to kind of walk people through implementation. We cannot provide a lot of support because we are a small but mighty team, but we're happy if people are using this. And with that, thank you so much. This is part of our team. There's also a lot of folks here if you have any questions. And well, we are hiring. You can see that link down there. We're actually hiring a senior UX designer with a focus on research for the Skate team, as well as a software engineer. So thank you so much. Any questions? I actually don't see the chat, so.
Let's see, we had some questions about the relationship between glides and Skate, although it looks like Ryan and Paul we have answered those.
Okay, I'm skimming through some questions. So you mentioned APIs. This is from staff. You mentioned APIs at the beginning of the talk. How do you actually communicate with CAD AVL and resource allocation systems? So I'm going to try to answer this, and Eddie, please let me know if I mess it up. So we have Transit Master is our CAD AVL system. We built an in-house middleware application called Busloc, which takes information from two sources of data. So we have Transit Master, and then we have Samsara. Samsara is just like some hardware on the bus that gives us the secondary AVL data. And so then Busloc pulls that information, does some pretty math, and then that's what feeds Skate.
Looks like we've also got a question about could Skate be designed to be used with on-demand applications? Is that are you referring to like non-fixed route service basically? Like, I think that's an interesting question. Like the route ladders view as it exists is very much based around scheduled service.
Yeah, so I guess like I see a lot of like smaller towns and cities getting into on-demand, right? Digital on-demand, like apps that allow like you have a fixed route, but like it's based on how much demand people put into an app, kind of thing. And it was a project that I had worked on for a little bit, and I was just curious if like you feel that this could like it could be adjusted to meet that kind of a need or that kind of an application. Yeah.
Oh, so you're saying like you have fixed route, but like kind of like particular like particular runs or like deviations and stuff are based on live feedback, basically.
Yeah, like it's almost like kind of like Uber, but for a fixed bus route. Right? It's like it's based on demand, like customers actually allocating demand, and then like it picks you up at particular stops, but it's based on how much demand actually is at that stop. Does that make sense?
Yeah. Yeah, that's an interesting question. Like I mean, you know, we're pretty good at like pulling in data from different sources. And so that's like probably sort of like if an agency had something like that, that's probably one of those sorts of things we could just you know, somehow integrate into the application. Since it like I don't know what sort of like for these sorts of setups, I don't know if like, you know, is you know, one thing is that, you know, Skate doesn't currently do any like on vehicle technology for like the actual, like, you know, the operator's MDT mobile data terminal and stuff. That's all still just, you know, provided by our CAD AVL vendor. So if you want to actually provide live information to the operator, then that is not something we would really support.
I got a question. Who is your current CAD AVL vendor?
Vontis, they used to be called Trapeze, but yeah, we use Transit Master. I see a question. What does the data flow in and out look like? So we consume, again, Eddie, you can help me out. We consume GTFS, exactly. Fastest exports, information from data from Transit Master. We also use the Swiftly API. And then Eddie, can you explain the out?
Yeah, I mean, so Skate is Skate doesn't actually produce any well, Skate doesn't produce any API feed type output. It kind of hooks into the rest of our bus data pipeline ecosystem. So you know, it takes data from our middleware and other sources, but that same data feeds into other parts of the MBTA's tech stack that then do things like feed bus data into Swiftly, who then produces predictions for us, and then we get that from them and integrate it into our public-facing GTFS RT feed and such. But that isn't that's part of other applications that we develop and maintain, like Concentrate.
We're short on time, but there are two questions that are good questions. So maybe I can take one, you can take one, Eddie. But is Skate able to optimize headway automatically or support dispatchers by recommended actions to them? So Currently, again, I mentioned bus officials. Most of our users are not dispatchers currently. That is our next big focus. We do have an experimental headway view in Skate, but there are many conversations around headway management happening at the T, so it is not it's not available to users. We also have thought about sending them recommended actions. However, it is a very human job, and that is the most, I guess, that is the most satisfying part of the job, thinking on their own. So it's not something that we have yet prioritized or really done a lot of research around. And what kind of service interventions do dispatchers often make using Skate? Dispatchers aren't, they may use Skate, but they aren't inputting service adjustments into Skate yet. That is, again, next phase. So that is the goal, for everyone in bus operations to use Skate to make service adjustments. So right now, officials at a station or at a garage or on the field, they may be using Skate to make a decision, but they are not recording the decision in Skate. Same for dispatchers. Dispatchers still use our software provided by our CAT AVL vendor.